Hey, class, I wanted to go back to the problem that we ended the section 11.7 on, and we were trying to find the volume of the largest rectangular box that could fit in here in this ellipsoid. And I wanted to show you we had stopped because the algebra started to get really a nightmare, and then the next section we're going to be able to do this problem a lot easier. So I just moved on because of time, but I do want to show you that you can do this problem algebraically. And so I'm going to do that right now. So just to remind you, we had this, this box. We have come up with the volume of that box has to be 8xyz. And then we said, okay, if we solve this equation up here for z, then we can turn this volume expression into an expression or a function in terms of two variables, x and y. So we replaced that z with this, and then we had, this was our function of two variables, and then we differentiated with, well, we started to go through the process to calculate capital, or not to calculate capital D, but to figure out where we might have max and mins, which means we have to figure out where the partial of the function with respect to x is 0 and with respect to y, where that's 0. So we started to do this. And so we took the partial of this with respect to x and used the product rule, and we got this. And then I used j for junk, and junk was everything under the root. And we got to this expression right here. And then we did the same thing, partial with respect to y. And then at that point, we said, okay, well, what can we do with that? Well, we took them and we got a common denominator. Okay, so we put these together and we got this expression. And then we put the common denominator here and got this expression. And then we said, oh, okay, a fraction can only be 0 if the numerator is 0. So we got that, and then this. And that's where we were. And then we said, if they're both equal to 0, let's just set them equal to one another. And then we went about doing this and kind of got stuck when we tried grouping. And then I moved on. Okay, so I'm just going to back things up. I'm going to go back to, let's say, this step here, where we were here and here. And instead of just taking the numerators and setting them equal to each other, I'm just going to take this numerator here, 8yj minus 18x squared y. I'm going to set it equal to 0. And now I'm just going to factor. So I can pull, let's see, a 2y out. I'll be left with a 4j minus 9x squared equals 0. And then because we factored it, we can set 2y equal to 0. And then we get 4j minus 9x squared equal to 0. And now this one here, this would give us a solution of y equals 0, but y being 0 means that the volume would be 0, because remember, the volume is going to be 8xyz, right? Z is a function of x and y, but if y is 0, then the volume is 0, and that's obviously not the biggest volume we can get. So I can kind of chunk that. I don't need to worry about that solution. But I am concerned about this. I really need to see where is 4j equal to 9x squared. Okay, so that's one equation I've got to figure out. Now the other one, I'm going to just take this up here, factor this one also. I can pull an 8x out. I'm left with j minus 9y squared equals 0. Again, this would say x is 0, but that can't happen or we'll have no volume. So that means we set this one equal to 0 and we get j equals 9y squared. Now, what we can do next is we can take these two equations and let's see if one thing I could do is just like to set them equal to one another. I can just multiply both sides of this by 4. And we get 4j is 36y squared. And now they're both equal to 4j. So I set those equal to one another. So if I set those equal to one another, I get 9x squared must equal 36y squared. And now, I don't know, let's solve for y. So I'll divide both sides by 36. And then I'll take the square root on both sides, and that will give me, oh, well, you know, that's 1/4. So take the square root on both sides, and I get 1/2 x equals y. And of course, we should do plus or minus because we took the square root. But again, going back to the idea that the way we drew the point that we were referring to, we went out on the x positive, and then y positive, and then z positive. So x, y, and z for us are always going to be positive numbers. So I'm just going to have y equals x, and that's it. So this is the relationship we have. In order to figure out where these partials are equal to 0, this relationship must be true. So now at this point, what I can do is I can take this equation here, j equals 9y squared. Remember, j was everything underneath the root. So what was underneath the root? This right here was what's underneath the root. I can take that, and I think I already did the work. Let me see here. Where is it? Okay, so I already did this work. So here, okay, is our relationship. And then we can take, where was it? Yeah, this one, j equals 9y squared. So I took that right there, j equals 9y squared. And then what I did is I replaced all my y's with 1/2 x. No, I did the other way around. I multiplied both sides by 2 here. I replaced all my x's with 2y. So this is j, okay? This is the j right here. That's what was underneath the root. And I replaced the x right here with 2y and then squared it. And then this equation is a quadratic equation with one variable in it. So once you start squaring things and putting things together, at the very end here, I trust you can do this algebra, you'll get y squared is 1/3, and then you take the square root on both sides, and you get y is equal to 1/√3. So we finally know what y has to be. And then x would be, well, twice y or double y. So we just double that answer and we get this. So what we found is a critical point, okay? We have a critical point that x is equal to 2/√3 and y is equal to 1/√3. Now, we don't know if this is a max or a min, but logically speaking, we know that it has to be a max because we have minimum values we can find easily because if x is 0, y is 0, or z is 0, then obviously we're going to have no volume. So this critical number must be a maximum. Now, I'm not quite sure we can be completely convinced that's a logical sort of like an intuition that we have that must be a max. In order to show it's a max, we would then need to go calculate capital D, which would take us doing, partials, second partials, and it would be very ugly. So I'm going to stop here. I just wanted to show you that it could be done, and that the algebra that we had run into in class was just because of the path that I had chosen, and that path didn't quite get us there. And I was thinking to myself afterward that what I did is I moved all the stuff with y's to the left and all the stuff with x's to the right. It might have worked if we did like all the stuff, like just bring everything to one, well, not everything on one side, but if we would have tried to factor this a little different, like maybe if we would have done these two together, right? Then maybe, and then those two together and tried to grouping, it might have worked. I don't know. I just wanted to show you a different way. So anyways, that's it. Thanks for your time.